maybe start, and I'll say a few words right after. And then Lewis, you'll introduce yourself, and then we'll just jump into the thick of it together.
Uh, Absolutely. Welcome everyone to Paper Club. This is a wonderful initiative, a collaboration between AI Thinkers and Human Feedback Foundation that Elena brought to us. And we decided to distribute it to the whole community. So I'm so glad that you're here. This is a really fun series. Today is very special. If you were with us last time on Paper Club, and let's just say what Paper Club is for those of you who are new, is obviously a live forum where you can hopefully have already read the research paper that we're featuring and then meet the author, get the overview, and interact and ask questions. And so it's a really great way to engage with people on the forefront of the research side of things. And if you were with us last time, you remember the discussion was with Mert from UC Berkeley, investigating the research. Why do multi-agent LLM systems fail? And it was very focused on specific current challenges, I think very tactical, kind of technical reasons why multi-agent systems commonly fail. It was research into that, and it included things like what we've all experienced if you're a practitioner: unnecessary repetition of things you already completed, or disconnect between the reasoning step and the actions that you need, or just proceeding blindly without maybe confirming that that's the right thing to do, not following directions, these kinds of things that we all face every day when we use agents. The more we dial it towards autonomy, and especially multi-agent, you get these emergent crazy failure scenarios. So we investigated that. Today, I'm very excited because we're sort of continuing this theme broadly of agents and specifically of multi-agents with Lewis Hammond, whose work focuses on the broader risks that arise from such systems as they, my thing is beeping like crazy. Is somebody trying to get a hold of me? Okay. I don't know why my computer's bleeping. So I guess you guys can't hear that. That's fine. But anyways,
Yeah.
today we're continuing this thing with a broader lens. Lewis's research focuses on the systemic risks that arise from these systems as they're deployed increasingly throughout society in finance, financial, military, and other critical infrastructure. What are these risks that arise? As these systems are much more complicated than single agent systems, maybe somebody should look into that. And I think Lewis realized that these risks have been systematically underappreciated and understudied. And so today we're diving into that. I'm so excited to have you, Lewis. Thank you.
Yeah, I'll quickly say a few words about the Human Feedback Foundation. So we are advancing more open and more human-centric future for AI. And this is one way we build bridges between the research community and the engineering applied side of AI, because you also don't want to build your products with yesterday's roadmaps. And it's important to connect with the researchers and ask questions directly, because we're applying and doing the applied work now. And so why don't we build better systems, which is hopefully everything we all want to build, that are useful for humans at the end of the day and respect our shared humanity and dignity. And so, yeah, and agency. And yeah, you can find us on humanfeedback.io. We do meetups with AI thinkers in Toronto. We run mentorship programs for emerging technologists and work with nonprofit sector in Canada to adopt AI and help accelerate responsible AI adoption. So that's us, and I will drop a link to my profile later. Now, Lewis, do you want to introduce yourself? We're really thrilled to have you. And before you do that, one last word I want to say is thank you to Mozilla, who helped us go through the papers and identify the ones we should be discussing. And this suggestion came from Amy, which is a research institute in Alberta in Canada. So thank you to them for bringing this specific paper to our attention.
Nice, thanks. Yeah, I have no idea who that might have been, but I'm also very grateful to them and very grateful to you for forwarding on the invitation as well. So yeah, thanks also kindly for the lovely introduction, Joe, as well. Given it, I can see you've clearly internalized the key messages of what I'm about to say already. So hopefully this is still interesting, but yeah, that's definitely the crux of it. So I'll dive in. I'll aim to speak for around 25, 30 minutes, and then hopefully leave plenty of time for discussion as well. I often find that's where some of the most interesting things are. So if I do cover things in like a little bit less detail than you'd like, then obviously do, bring those up in the discussion. Yeah, very quick introduction on me. I am the research director of the Cooperative AI Foundation, which is a UK-based non-profit field building organization that works to build the field of cooperative AI. I'll tell you a tiny bit about both of those right at the end of the talk. I'm also just right now in the very final stages of finishing up my PhD at the University of Oxford, where I've been for a number of years now. And I work on things that are, well, lots of different things, but mostly things that I'll talk about in this talk. Okay, so that's me. And now hopefully my slides will advance and we can get on with it. Yes, cool. Okay, so the paper, the project at the aptly titled Paper Club, or the presentation rather, at the aptly titled Paper Club is about this paper about multi-agent risks from advanced AI. So it's available online. If you haven't already had a look at it, then I would go and do so. It's quite long, but there's a very short and easily digestible executive summary, and it's meant to be dip in and outable of. Okay, but for the purposes of this talk, I'll introduce some of the kind of new multi-agent systems that I expect will be coming online soon. I'll talk about the main contributions of this paper, which is really a taxonomy of risks and kind of things to be aware of and how to think about the sorts of issues that we might soon begin to see. I will talk a little bit about some kind of interesting research directions that I am excited about. I'll flag this stuff about cooperative AI just as a thing to be aware of and maybe a thing to get more involved in for some of you. And then hopefully leave plenty of time at the end for discussion. Okay, new multi-agent systems. This is the kind of like jumping off point for the kind of report and for kind of, in some ways, my kind of worldview. We're all hearing lots about agents these days, and people are very keen on building agents, using agents. What is an agent? It's like actually like harder to say. Is it a chatbot? Not quite. There are a few different kinds of things that characterize agents, and probably as people who are kind of maybe on the more building-y side of things, you're all too aware of these things already. But I'm thinking about the level of autonomy, the level of capabilities, the level of being able to complete tasks over longer time horizons and things like this. And these are the sorts of things that kind of get us towards a kind of slightly more kind of agentic looking system. But it's a bit of a fuzzy notion, again, as I'm sure you're all aware. And agents, the idea of agents is not new at all in AI. This has been something, AI in some ways is like, the science of kind of building artificial intelligent agents. But one thing I do want to flag is that most multi-agent systems these days that you see in the real world, LLMs kind of aside, because we see a few kind of bits on the research frontier of people using multiple LLMs and things like this, but they're not really out there quite yet. So most multi-agent systems that do exist in the real world are things like robot warehouses. And robot warehouses are very different for the sorts of things that I'm going to be talking about. So in particular, they are structured environments where the agents can't do very much. The agents are not very capable. The agents all have very similar objectives, right? It's not like they're fighting to get like packages off the shelves. They all have like aligned objectives. There's often a system designer who can keep an eye on everything and make sure all the robots are acting in check and kind of design them and so on. There's only one person in charge, etc. So all of these things, nice structured environments, very simple in many ways, are not what's going to be the case when we have more advanced AI agents running around under the control of different people. So yes, settings with multiple AI agents that interact with each other, that adapt to each other, are rare, and this is going to change pretty soon, I think. So performance and publicity is going to drive adoption of these AI systems, as we're already seeing with the case of non-agentic systems. If we have agents, if we just have more of these agents, and if we have a greater number of modalities and interfaces via which they can interact with one another, then that's going to lead to more interactions between these agents. And this is a point that I sometimes think goes a little bit underappreciated, but when these agents are interacting with one another, it's going to be strategically advantageous, competitively advantageous to them in order to be able to adapt to other agents and act more and more autonomously. And this is something that we don't see very much of yet because we're in this kind of like train, test, train, deploy paradigm or whatever, where we like pre-train a massive model, we maybe construct some scaffold around it to create an agent, and then we deploy it. But then the agent doesn't really update or do anything over time. Maybe it gets occasional updates, right? It gets a little bit of fine tuning here and there. It gets maybe given some recent kind of like tweaks, but it's not really learning online. And this is one thing that I think will change purely because it'll be advantageous for people to do so from a competitive perspective. Okay, so that's the current like trajectory that I think we're on. And you might ask like, well, so what? Like, why would that matter? This seems like business as usual, but now we just have more of these things running around. And the point is, I think that there are some things that can go wrong. So yeah, maybe I think there's like quite a number of people in this call, but I will try and make it like at least somewhat interactive because I think it's just fun and also keeps people paying attention. Who knows what this graph is? You can just shout out. There isn't a prize, but you know, the admiration of your peers.
Automatic trading.
Yeah, very good. So the clue actually in many ways is on the bottom axis, which you'll notice this all happens very quickly. And in fact, that the speed of which this big dip happened, that's the y-axis is I think the Dow Jones index. And this graph represents the flash crash that happened in 2010, which was a crash caused by, as Ramon said, some automated trading agents that got locked in this kind of horrible feedback cycle where they kind of like crashed a bunch of stocks and managed to wipe about $1 trillion off the US stock market in the space of about 25 minutes. Before, kind of magically, they slammed on the brakes and everything kind of bounced back, which is one of, in some ways, like the most interesting things about that whole event. But why I mention this is because it's one of the few instances where you have quite autonomous artificial agents and systems acting at speeds and scales where humans aren't easily able to keep an eye on them. And indeed, that's the entire point of why people deploy these systems in the first place, is because they act faster and at greater scales. Oh, did my screen sharing just stop?
Yeah, sorry, I realized I had it turned on for everyone. And so I wanted to mitigate that. It seems like I turned it off for you as well.
Okay, no worries. I'm coming straight back.
Apologies. I will.
All good. I think I can just click the button again. Okay, resuming where we left off. Brief interlude. Okay, so yeah, it's one of the few instances where you have these systems acting at scale in these high stakes environments. And importantly, the agents don't all have the same objectives. They're acting in this kind of competitive scenario. And this can go very wrong. Another instance where agents or people, actors, quintessentially do not have the same objectives is, once my slides advance, in military scenarios. So this is a video from Palantir, which describes their AI war planner, which is basically a large language model powered kind of military strategic decision-making assistant. That's a picture of a tank in the satellite image on the right, in case you couldn't decipher that. And at the moment, these are just strategic decision support assistants or whatever, right? But I don't think it takes too great a stretch of the imagination to see how agents might soon be used a little bit more autonomously in military situations as well. And all of this is extremely high stakes, of course. So I'm mostly going to be talking about doom and gloom for the rest of the presentation. But I do just want to flag that there are some potentially amazing applications of AI agents as well that I think could honestly just be one of the biggest differences to the way the world works, and in potentially really, really good ways as well. And this kind of decentralization and kind of multi-agent approach could be, in some ways, one important way to distribute some of the benefits of AI. We can imagine a world, if AI agents end up much better at cooperating or working with each other than humans sometimes are, we can imagine a world mediated with AI agents that just kind of creates these Pareto improving outcomes for everyone. On the right, bottom right here is some cool work from Google DeepMind, where they used an AI agent, an LLM-based agent to help humans with different values and perspectives and objectives find consensus by acting as a kind of mediator. I think all of these technologies are, yeah, really, really important, and I'm very, very excited about them. So I am going to be a bit of a doomer for the rest of the presentation, but I'm internally an optimist. Okay. So main bulk of the paper then, main ideas that I want to get across is like, okay, so that we've just seen or just speculated about some ways in which things might go wrong. How should we actually like start to get a handle on things that can go wrong? So how can we start looking out for them? Okay, so there's I guess like two ways that I want to try and carve up this space. The first is from a kind of like abstract kind of game theoretic perspective, and the second is going to be more looking at like specific sorts of dynamics that we might see emerge. So to begin with the failure modes, then at a very, very high level, there's a few things we can think about. So for some reason I keep. Okay, no, it is working. Okay, that's fine. So first we can ask, like, do we actually want the agents to be cooperating or not? And lots of the time we do, so cooperation is desirable. And then we can think about the objectives the agents have. So in a lot of cases, and especially in a lot of cases today, the multi-agent systems that people are building, say with LLM agents, everything's common interest, by which I mean all the agents like more or less have the same objective. They might be given different roles, but they're all driving towards the same direction. This is just a common interest setting. And so failures here are just miscoordination. All the agents more or less want the same thing, but they just, for whatever reason, they're not very capable at getting it. Okay, maybe try that. Second scenario, which is more general, is mixed motive settings or general sum settings. And here the risk is conflict or cooperation failure of some sense. Yeah, this also includes things like tragedies of the commons and other kind of like classic failure modes that you might have come across before. Then there's kind of constant sum settings, which is just a generalization of zero sum. In this case, it's kind of definitionally impossible for the agents to cooperate because one agent's gain is another agent's loss. So cooperation doesn't really make sense. And then finally, there's this category of outcomes where we actually might not want the agents to cooperate. And then the risk is that they collude with one another and work together when we don't want them to be working together. And obviously, the canonical instance of collusion being a bad thing is stuff like markets, where kind of competition kind of is actually what drives efficiency. But eventually, and maybe even relatively soon, some of the most compelling proposals for keeping very advanced AI systems safe and aligned with what humans want them to be doing use implicitly multi-agent setups, or kind of they use AI monitors to oversee agents, or they use kind of adversarial training or things like this. All of this breaks down when the agents are kind of working with each other in ways that you don't intend or expect them to. And so collusion is also a risk in those sorts of areas too. Okay, so that's the kind of very high level kind of picture of the sorts of things that can go wrong. I will now go through just some of the kind of key risk factors that can lead to some of these things emerging. So this is, bear with me for a second, this is going to be just like a bit of a laundry list. I'll go through all of them quite quickly, and then if there are any that are interesting to people, we can dig into them a little bit more in the discussion. So, for some reason my slides, okay, whatever, they keep not advancing. Anyway, okay, so there's a bunch of different mechanisms by which these failure modes can arise. So first one, information asymmetries. You have information that I don't, or vice versa. Maybe I'm strategically withholding it from you, maybe I'm ignorant, and this means that we're going to get into, we're going to fail to cooperate, or we're going to end up in some sticky situations. Network effects. So the idea that agents that are connected to one another can fail at the systemic level at ways that individual agents that act in a vacuum cannot. There have been some interesting results already showing that kind of we have these kind of infectious jailbreaks that can spread from one LLM agent to other LLM agents and so on. Yeah, which they obviously couldn't do if the agents weren't talking to each other or interacting with one another. There's selection pressures that might emerge. So this is more important when these agents are being optimized and are learning in the presence of other agents. But it can also occur at the level of kind of firms and agent developers, where the market pressures might incentivize people to deploy agents with certain kind of characteristics. There's also some interesting issues here about the training data that the agent's learning from, effectively selecting for certain strategies or ways of thinking that we might not want. So humans, for example, have this thing sometimes called what's referred to as fixed pi kind of bias or fixed pi syndrome, where we sometimes perceive the world to be more zero-sum or competitive than it actually is. And this leads us to take actions that might not result in the kind of best outcome for everyone. Okay, destabilizing dynamics, that's the kind of flash crash thing I was talking about before. You got these feedback cycles and other sorts of things. Issues of commitment and trust are kind of exactly what it says on the tin. By default, we might just end up with a world in which we have like millions, billions of these agents running around on the internet, just like doing stuff, interacting with things and people and so on. And, you know, I think already kind of we're seeing issues of kind of trust in these kind of systems and systems that we might not know are human or whatever being kind of eroded, which is an issue. Emergent behavior is a little bit more speculative. One thing I'll flag here is I'm not talking about emergent behavior in the way that some people currently or talk about it, which is that, you know, you stack more layers, you add more parameters, and eventually these capabilities emerge, right? That's a classic way that people talk about this. What I mean here is I mean emergence at the level of the collective group of agents. So the idea would be that no individual agent possesses some kind of capability or disposition that leads it to exhibit some behavior, but the group collectively might. And so there are already kind of interesting case studies where, you know, we currently safety test all of these agents and so on their own. And yet when you combine them with one another, they're more than capable in some cases of overcoming some of the safeguards that are put in place for individual agents. Okay, next one is a bunch of security issues. So there's a bunch of new attack surfaces when these agents are interacting with one another, as I spoke about a little bit when it comes to these infectious jailbreaks and so on, and the communications between agents, transfer of information, important data, and so on. But also potentially these collectives of agents open up new attack vectors as well. So some security attacks, so things like classically DDoS attacks, succeed insofar as they are kind of distributed, and we might soon see some kind of attacks that look a bit like that in the context of agents as well. Okay, so all of these factors can be kind of problematic independently of those three big kind of failure modes that I mentioned before, conflict, miscoordination, and collusion. And they're clearly like not exhaustive or mutually exclusive. There's a lot of overlap here. Often many of these risk factors are going to play a role. And you'll also note that these risks are not unique to AI systems, right? So all of these things we have kind of seen instances of in the real world already with less sophisticated systems or with humans and so on. The challenge is, of course, that AI agents are different from humans and other sorts of actors in important ways. And it's these differences, so the speeds, scales, autonomies, etc., levels of autonomy that which these agents are able to interact at, their ability to transfer information and to process information at scales that humans cannot do, things like their ability to be copied and cloned instantly, things like their ability to be kind of modified or these sorts of things. These are all things that just don't apply to humans or other sorts of actors when we usually think about some of these problems. And so these problems kind of change in their nature. Okay. So yeah, lots of implications here for existing work in AI safety, AI governance, AI ethics, but also just people in the real world, like building and working with these systems and so on. I think these are all quite speculative right now, right? Because we don't actually have these multi-agent systems yet, but it's quite clear that it's on the horizon at this point. So the time to think about it is now, not like, you know, everyone knows. I hope everyone who was, you know, here during COVID has now internalized that if you have an exponential looking graph, the time to do something is not when the exponential is like looking a lot more vertical. It's like very early on, right? Because that's when the interventions actually make the difference. And I think this is the case here for the AI as well. Okay, so very briefly, I'm going to wrap up with just some like cool research directions that I think are exciting right now. I'm working on some of these. We're funding work on others of them. Yeah, excited about more people working on these things. I think it's very underappreciated. So this is where I momentarily just get on my little soapbox and I tell you all that you know, these these things are very understudied right now, and people are not paying enough attention to them, given how significant I think the issues are. And there's a bunch of different reasons for that. So as I said, current multi-agent systems are kind of rare or quite highly constrained. We don't see very many of them in the real world yet. And we're only, when it comes to LLM agents, we're only even just barely capable of building the things, let alone kind of like worrying about like what happens when they kind of, yeah, just making them work rather than like what happens if they work too well in ways that we don't intend is the issue, really. So yeah, there's a bunch of like single agent safety issues, like security issues, alignment issues, robustness issues, all of these things that are like not solved already. And multi-agent safety stuff seems like kind of hard compared to those. So yeah, that's another good reason to like focus on the single agent case. And also some of these topics, many of the things that I've proposed or talked about in the previous slides are not purely like technical issues, right? They're socio-technical issues. They require governance, both of the people deploying those agents and maybe even conceivably of the agents themselves. So yeah, this is like, when I give this talk and I try and like get researchers and people thinking about things, this is my kind of like cartoon that I sometimes give, where I'm like, here's a bunch of people building applications of AI agents. Here's a bunch of people like driving fundamental capabilities. Here's some people thinking about like safety and like what happens if like we get AGI and things like that. And then here's people thinking about like multi-agent safety stuff, which is even like a smaller subset of that. And like one way you can cartoon and like characterize my job is like I try and make this red bar go up. That's my purpose in life these days. And that's why I'm giving this talk. Okay, and you too can help this red bar go up if you want to. You can get involved. You can do stuff. There's a lot to be done. And speaking of a lot to be done, here are some interesting directions that I think people should maybe consider pursuing or thinking about. Okay, so first is like developing evaluations of cooperation relevant properties in multi-agent systems. So like we test these systems completely in isolation right now before they're deployed, basically. We don't test them interacting with other agents. We don't test them interacting often with, maybe they interact with one human, but not like a bunch of humans and things like this. And also like measuring like how good the agents are at cooperating or working with each other in these sorts of things or working with humans is actually just something that's kind of tricky to pin down. And so there's, I think, a lot of work to be done, both on the like conceptual and also the empirical side about like how do we build evaluations for multi-agent systems. Study of like special properties of AI systems, such as their transparency. Like in theory, we can just look inside their parameters. The fact that we can replace them. How does this impact the abilities of agents to cooperate or interact with one another? Methods for detecting and preventing collusion between AI systems. Lots of people have like trained some reinforcement learning agents and just like, shown that they can learn to cooperate in the prisoner's dilemma or some like basic toy market scenario or something like this. But it doesn't actually like lead to us being able to like detect collusion in much more complicated settings and eventually even then prevent it when we don't want it to take place. Yeah, a bunch of conceptual and theoretical work on capabilities and dispositions, as I mentioned before, when it comes to evals. This is something I'm working on at the moment, scaling laws for strategic interactions. So what happens if you have a bunch of strong agents and a bunch of weak agents? Like how does that impact their interactions and the outcomes? I think there's also some interesting ethical questions there I'm working on at the moment with some people to do with access to different levels of agents. You might think that the fact that we're moving, for instance, to a kind of inference time compute paradigm means that unlike when we just like pre-trained a big model and then, it costs the same to do inference for everyone. So like, if you can pay the whatever subscription or the like, token cost or whatever, everyone can have access to the same model. It's like not that high. Now we're moving to a world where like, if I can spend like $1,000 on inference time compute, like I'm going to get probably like a much better answer than someone who can spend like $10 on inference time compute. And so we end up in a world where actually like people who already have more resources can benefit more from these things, which could entrench existing inequalities and so on. So I think that's a kind of interesting question and the one that we might have to grapple with reasonably soon if agents end up being extremely important in the economy, as I suspect they will. Cool. Principal scalable methods for training processes and interactions of AI systems. So there's like loads of interesting ideas in like things like fields like mechanism design, game theory, and so on for how you might actually solve some of these problems, but they don't really scale to the like big systems that we have today. And so the question is like, how do you get them to scale? Yeah, investigations into very specific failure modes. So I mentioned some before, but I'm thinking specifically here about like, okay, what happens if we have agents deployed in like they're kind of like controlling critical infrastructure stuff? What happens in financial markets? What happens in, you know, maybe military domains? What happens in these very high stakes areas? And how can we prevent things going wrong there? Yeah, using AIs to enhance humans cooperation. This is something I gestured at before, but haven't spoken much about. I'm very, very excited about work in this area. I think there's tons of low-hanging fruit. Could be like some massive wins to be had here. I think it's great. And then, yeah, a bunch of technical work that needs to be done to support governance efforts as well. So like lots of these cooperation problems and tricky kind of thorny multi-agent risks might actually be partially addressed by just good governance. But there are some technical challenges that need to be kind of solved in order to like make use of that. Okay, that's my main thing over. I'm just going to very briefly just flag Cooperative AI. So I work at the Cooperative AI Foundation, and then Cooperative AI itself is kind of like the research field. It's basically the kind of research field that's working on all the stuff that I just spoke about. So yeah, it's a subfield of AI. It studies cooperation problems, including when we don't want agents to cooperate as well. So yeah, and they can involve humans and machines, organizations. I just mean groups of humans and machines here. And yeah, the aim is both to help reduce risks from resulting from these problems that I just spoke about, but also as well increase the gains from AI mediated cooperation as well. And so yeah, it's all about kind of understanding and controlling the cooperation in the context of advanced AI. And I've spoken a little bit already about why cooperation problems are different in the context of AI, or they could be. So I'm going to skip over these bits in order to get to more discussion. But yeah, lots of stuff to be done here. It's a very growing and nascent research field. And yeah, I think it's very important. And then, yeah, just a very quick plug for us. We're the Cooperative AI Foundation. Here you can see our trustees, staff, and advisors, respectively, probably some faces on there that you might recognize. Yeah, so you're aware we are a UK nonprofit. And we just do all the things that you'd expect people to be doing. So we do grant making, we do research, educational stuff, yeah, research grants and PhD fellowships, workshops, contests, hackathons, or at lots of the major conferences. Yeah, we collaborate with some of the big labs and kind of other big universities quite a bit as well. Yeah, summer schools, there's a kind of, there's like now an online curriculum for learning about this stuff in case you're interested. You can find that by just going to the website. Yeah, technical reports and research agendas, the sorts of thing I've been talking about in this talk, and some stuff as well on policy engagement and AI governance. So yeah, just basically, yeah, if you're interested in all of this stuff, like cooperativeai.org is the website, and we have a mailing list, which is going to be more active soon, where we just will kind of like, yeah, let people know about opportunities to work on this stuff or just to hear more about some of the important developments. So yeah, that's it. Thank you all very much for your attention, and looking forward to hearing any questions or comments or that you might have.
Wonderful.
Amazing. So we'll get into Q&A now. And Joe, why don't you kick it off? And then if you want to raise a hand and get unmuted, just do that. I will also pull questions from the chat and we'll send you a quick message so you know you'll be talking next. So
Great.
yeah.
So thank you so much, Lewis, for joining us. And just a quick plug for AI Tinkers in Europe and in London. You know, if we want to do hackathons together or things like that, this is probably a great synergy to work together on some of that stuff. So we should definitely talk.
Yeah, absolutely.
And then as far as questions go, the one that I had was there's a field called system dynamics. Jay Forster, John Sturman at MIT, which studies how complex systems interact in unexpected ways. Feedback loops, time delays, and nonlinear interactions often lead to systemic emerging behavior as a whole, and that's interesting. And so the classic, you know, applications of that field are like economy and global trade, but also like supply chains. I think we're all familiar with like the bullwhip effect. Each person who manages inventory in a warehouse is looking at like their good intentions, and they have demand on one side and they have to restock their supplies on the other, and there's time delays. And there's this emergent behavior where if you get a sudden spike in demand or unexpected, you know, everyone's acting in their own best interest, but it can lead to a bullwhip effect where suddenly you have incredible overages in inventory and it's chaos and, you know, these emergent things, right? Every factory, inventory person is like an agent in a multi-agent system. So my question is just like, have you looked into that field of study, which is before AI, but may have some parallels in terms of how we might think about mitigating or what the common failure modes are?
Yeah, so in brief, I have looked into it a bit. It is definitely less my personal area of expertise, but it is an area that I think is very important. And I wish we had more people with expertise in those kind of themes, who, complex systems, complex adaptive systems, these sorts of things, who could actually weigh in on some of these issues. One of my co-authors for this report, or a couple of my co-authors for this report, do very much have that background, and so they were able to comment on some of these kind of like network effects and kind of destabilizing dynamics that only really emerge at these sorts of scales, and that can be quite unpredictable. I think at the moment there's still a lot of research to be done in like joining up the sorts of like small kind of demos and simulations that people have with the kind of few kind of frontier agents, and then these very, very kind of like um, coarse-grained, high-level kind of like agent-based models and simulations that people will run on the other hand. And I think there needs to be some kind of like middle ground, or at least some way of kind of more readily translating the insights from one to the other. But absolutely, I think those ideas are going to become increasingly important when we need to think about this vast number of these agents that will be coming online soon.
Great. How about we jump and take a few more questions from the chat? And while I'm looking for those, Toby, I'm unmuting you.
Sure. The question that I have, the question I have is really around, so there seems to be like a different kind of, there's a gradation of like the level of openness of multi-agent systems, where you might have on one end a very like closed multi-agent system, maybe it's owned by like a particular company or enterprise, and all the agents in that system are like known by that enterprise. And on one other end of the spectrum, you could have a very open multi-agent system where anyone can deploy an agent that interacts with other agents on that system. In my own line of work, I'm more so looking at building the primitives for that more open end of the spectrum. But it seems clear from this talk that the risk changes as the spectrum of openness changes from across the multi-agent like openness spectrum. And so I was just wondering, like, in terms of like thinking about how do you monitor, how do you evaluate, how do you even reason about like the different risks that emerge across the spectrum of openness of a multi-agent system, or the spectrum of like who can participate? Are there existing frameworks of research that you're aware of about how do you like think about this? How do you think about how risk changes as this system becomes more open? Is there any prior literature you're aware of in that space?
That's a really great question. Yeah, and I think you're right. I think your point is absolutely right. Like when you have these systems in a kind of relatively closed setting and they've all got roughly the same objectives and people can monitor them, then that's, even if we have more advanced AI agents, it's closer to these kind of like simpler, or at least more kind of like straightforward in terms of like what can go wrong or like what to think about, scenarios that I painted to begin with. Um, yeah, I think when it comes to, so another area that I really don't have enough expertise in, given that I try to think about some of these questions, is stuff like kind of existing work on kind of like networks of computer systems more generally, and yeah, how that works and how those are secured, and obviously, the internet is maybe the ultimate kind of paradigm of like this kind of like open, uh, kind of like, I guess, like substrate via which like different entities can interact with one another and so on. And yeah, I think I don't have like a clear story of like how to think about like how the degree of openness, uh, depending on how that's cashed out as well, can can lead or not lead to some of these risks. I mean, you could kind of go through some of the existing risks in the report and be like, okay, this clearly requires like this degree of openness because like, if they could just shut off this bit, or if like these agents didn't all had the same objective or whatever, this would like not be an issue. networks failures or whatever can only spread insofar as there's like an actual network for them to spread through, and those things are interconnected and so on. So yeah, most of the things that I have thought about or spoken about just assume that there is this kind of like open-ended, like fully kind of open-ended, open kind of system that people can just plug and play in and interact with, mostly because that's kind of how the real world works right now. And I eventually just expect AI agents to be able to just like make use of computer systems and software and all of these things in exactly the way that humans can do. And so I don't really expect it to be like any less open than that, unless we take some like serious and very radical governance steps very soon. I don't see that happening. I do think there are interesting questions around like, in the same ways that we built like some of the kind of communication and security protocols for the early internet, there might be interesting analogies here about like how we build like a kind of like agent level to the internet and the ways that agents interact with one another, and especially when it comes to very safety critical applications and so on, we might actually want to restrict the ways that agents can operate with one another. We might want to close off some things and make them a bit less open. And yeah, I think that's kind of like an open question about like, haha, no pun intended, about where and how we do that. But I think it's a really good point.
Yeah, great. Thanks. Gab, you're next.
Hi, thank you. So you partially addressed my question in this answer you just gave, but there seems to be a huge gap between theory and practice in understanding multi-agent dynamics, and this makes it kind of hard to come up with like actionable or like useful mechanisms that you can use today practically for real multi-agent settings, like safety settings where it's important. Part of this is like theory of stuff working in a very general set of assumptions, very broad a lot of times, because there are no concrete settings to latch onto and then say, this is what the reasonable assumption is. Do you think we have time to, once the concrete setting arises, impose those assumptions and adapt accordingly? Or do you think we need to set up the guardrails ahead of time? And then, yeah, then like say, here are the concrete settings that you should pursue, or if you're not there, here be dragons type of thing. Yeah, I guess 40, that was open-ended, but.
Yeah. No, I think it's a good point. I agree with you that there is often this disconnect between the theory stuff and the real world stuff. I got at this slightly when I was talking about the complex adaptive systems type perspective on things, where we have these like, these models, and we want to try and actually connect them to like what the sorts of systems that we might see in the real world. I think exactly the same kind of complaint can be levied at maybe some of the more like game theoretic work, where we have these like toy models of cooperation and so on between these rational actors, and they are like somewhat predictive, but they definitely fail. I actually think in some ways there's like an interesting case that some of these game theoretic models that assume kind of like hyper-rational agents and stuff like this might actually start to be like more appropriate when we have like ruthlessly optimizing kind of like AI agents and computer systems, rather than kind of like fallible, bounded, kind of biased, kind of sometimes a bit dumb humans trying to do these sorts of things. So that might start to be somewhat more applicable. I suspect that in a lot of cases it will be hard to do work in advance. I think there are some things that we can start to do already. So we definitely can start to just evaluate multi-agent systems when we do our kind of like set pre-deployment testing and so on, and like safety testing and so on. Like at the very least, we can like study how these agents interact in like kind of like two-way interactions with one another in like various kinds of settings. There are some evaluations that we were developing recently with the UK government's AI Security Institute on the extent to which agents can kind of like manipulate or kind of coerce one another and things like that if they're kind of trying to. And that's just like the sort of thing that we might actually start to see in a bunch of different places, and so on. Obviously, if we're talking about some of these like really big kind of like large scale kind of like network failures and things like that, that only emerge when you have like thousands, billions of AI agents interacting, then I think the case there needs to be made more for kind of like what sorts of information would you need in order to be able to detect that? So like what sorts of things are you monitoring? Is it like where agents are deployed, how much they're interacting with one another, what the kind of like computational resources or other things that they have access to, what they're in control of, these sorts of things. There's cool work on this this is done by some folks at Stanford called ecosystem graphs, which is thinking about kind of like documentation for kind of large networks of agents instead of just these individual systems that are deployed kind of solipsistically. And then I think the other thing we can do is maybe look for inspiration at other industries who've had to deal with this. So I'm currently supervising a project which is looking into like how do people work, like what regulations and technical kind of things have people put in place to prevent the next flash crash? Why have we not had any more flash crashes? This is a good thing. And I assume lots of people who are very clever have thought very hard about these problems and how to avoid them. And there might be some kind of interesting ideas that we can kind of lift from there to try and like preempt some of these failures when it gets to the case of more sophisticated AI agents. But yeah, I also think it's, as much as anything, it's just something to be kind of like very aware of and mindful of, and it will be hard to anticipate all of these things. Though that doesn't mean we shouldn't try.
Sounds
thank
good.
you.
Jonathan, do you want to jump in next? And we have quite a few questions. Let's keep moving.
I can try and keep my eye.
Yeah, sure. So I come at this kind of from a different angle. I come from an audit firm, so I think about the end use all the way back in. And so if our end goal here is to get things into production and in use, I think about like SOC certification. And so if we're going to be in a multi-agent framework that is probabilistic and interdependent, interoperable, like what would need to happen from an evaluation and monitoring perspective to get a SOC auditor comfortable with that thing? And then at the same time, balance the economics of the overall solution becomes really hard. And then, of course, in my world, like very meta, how do you evaluate the evaluator? Because inevitably, that's what the auditor will inevitably start to do. And then lastly, the types of evals that we do, pre-prod versus post-prod, will need to evolve and change to make sure those economics stay in the right favor to continue to push forward. So I guess any reflections on that?
Yeah, I think I just like mostly agree with the sort of like sentiment that you're sharing. I have less expertise when it comes to kind of these sorts of things. I have heard the idea floated that okay, we are probably going to want independent auditors and independent model testers and so on. But again, those are presumably going to need to be kind of certified in some sense, or kind of so that the auditors can be like, yeah, they're doing a good job. They when they say that something is the case, we believe them. And maybe also as it increasingly becomes the case that these models become very powerful. And the state starts to take a major interest in them, and also to the extent that these systems are proprietary, we may actually need things like the UK has an AI Security Institute right now. The US kind of has the remnants of one, I think, and there are others kind of floating around. To the extent that these systems are deployed kind of publicly as well, we may want, and also to the extent that the only people capable of mandating that these models are tested sufficiently rigorously, then there may need to be kind of people involved from those sorts of places as well. So I think those that will be important. Yeah, it is obviously very hard to like kind of, to the extent that your agent is just out there in the world doing everything and you need to like figure out all of the ways it could like possibly go wrong. I think there needs to be kind of clearer lines at the moment on liability for model developers and so on. I think I've heard people who know much more about this than me say that this is something that we don't yet currently have a good kind of like full kind of like liability regime for much more autonomous systems. And certainly when it comes to kind of like multi-agent failures, you might need kind of like things like joint liability and stuff like that as well. So you might need to be kind of borrowing quite a lot of those existing sorts of ideas from the kind of legal kind of area as well. Again, not very much not my area of expertise, but I do know a few people who are now thinking about this quite seriously. So yeah, Noam Colt is doing some great work. He's based in Hebrew University. He's got a good paper on governance of AI agents. Peter Wills as well, Gillian Hadfield. These are all kind of more legal scholars who've thought very carefully about the kind of liability side of things. But I think it's very important.
Thank you.
Kiran, I'm unmuting you. No? Okay. Joe, do you want to talk about the human in the loop maybe for a second? How would that even work?
Sorry. Oh, because I posted something.
Sorry.
Oh,
think
Kiran is.
I was curious about mitigation. I was thinking about mitigation strategies in the world in the future, like, you know, kill switch or like mandated regulations around having human in the loops in some of these systems for critical steps or something. Have you started to consider like what is the future research direction and the mitigation steps and what those would be and how do you test them in the context of actually having efficacy towards mitigation?
Yeah, I've thought about a little bit about these things. Recently, towards the end of last year, I worked on a paper with some folks called Open Problems in Technical AI Governance, which is basically laying out a suite of kind of technical problems, like things like compute monitoring or kind of, how to have kind of humans in the loop in various sorts of settings. Maybe how to have how to be able to kind of like reliably shut down agents and these sorts of things if we need to in a bunch of different places. And yeah, the sorts of technical developments that are needed to kind of facilitate some of those things that might be necessary, as you say, for kind of like more safety critical areas or things where we do want a human in the loop for certain things. So I think that basically there are kind of like number of challenges there that kind of like society has to decide on like how we want these systems to be used and where we want them to be put in place, which by the way, I don't think we're really doing right now. The companies are deciding that, and then society is just along for the ride. So I don't think we're having much democratic oversight over these decisions right now. But then following that, then there is the question of like, okay, well, we do want, there to be like some way of shutting down these things or some degree of accountability or some ways of like monitoring like what's going on here. And then there's like some technical questions that then follow from that. But putting those technical solutions in place earlier kind of like puts more policy options on the table and potentially can lead to some kind of like win-win scenarios as well, where we don't have to worry about like overly invasive monitoring of AI agents and things like that if we've already developed a bunch of like clever privacy preserving technologies that can give us both the kind of like security and happiness to deploy these systems in very like kind of private areas or these sorts of things, while also being like happier that if things do go wrong, then we have recourse there and we like are going to be able to maybe foresee this or better understand this. I think there's definitely things to be done. Would recommend having a look at that paper for a bigger kind of overview of that stuff. It's a great question.
Yeah, you hinted on
Amazing.
being able to foresee, like it seems that even just simulations might be an interesting avenue because
Definitely.
you can help at least understand before you make decisions or put systems in place.
Yeah, absolutely. No, I fully agree.
Great. There is a few questions here from Zoom user who is not in an environment where he can ask those questions directly. So I'm just scrolling through and trying to bring them in. There's a few. I'm seeing one about the emergent collective agency from LLM systems and whether that would require ethics encoded at the swarm level, not just per model. Any comment on that?
Yeah, I think it's a really good question. I'm going to push back slightly on the idea of like encoding ethics, although I do want to also kind of acknowledge the fact that like implicitly a bunch of kind of like ethical perspectives and values do get baked into these systems. So that happens. I think there is like an actual, so speculating about these emergent capabilities is like one thing, right? So we can say that like maybe like a ton of like 1,000 agents could do something that like no single agent can do. That's not that hard to imagine. We can probably think of things nowadays where if we are able to successfully orchestrate 1,000 agents, they would in fact be able to do things that fundamentally individual agents cannot. The different dispositions, so there's an orthogonality here, there's orthogonality thesis idea, it's due to Nick Bostrom, between kind of capabilities and dispositions, right? So like I can be super capable and have like horrible aims, or I can be like very, very incapable and like want what's best for humanity and like, you know, be great. And all, these things are completely different from one another. Like just because I'm smart doesn't mean I like want good things, and just because I'm like dumb doesn't mean I don't want good things, and vice versa. Okay, right. So that applies to AI agents. And the stuff about emergent dispositions, I think, is a lot more speculative. One thing that you might see, which is like relates to this idea of like shutdown and so on, which is like the kind of one of the archetypal kind of like AI worries, where like basically a system has an objective, and like in order to complete its objective, it needs some kind of like notion of self-preservation and these sorts of things. Now, at the moment, we're like interested in training agents and encouraging agents not to think that way, and that if they, you know, if we want to shut them down, then we do actually can shut them down quite easily. As soon as, so that might be the case for any individual agent. When you then stick all those individual agents together, they might still not necessarily be interested in self-preservation, but the structural incentives presented by the fact that they're all working together in tandem may give them a large incentive to essentially preserve the overall system's existence, or the existence of each other, and so on. So in the same way, for example, that like any individual ant, when like it attacks a predator much larger than it, doesn't really show that much kind of regard for self-preservation, but it's in service of protecting the colony, right? And if individual agents end up doing things like that, then we might see these kind of like emergent dispositions as instead of just these like emergent capabilities. Though I'll add that this is like extremely speculative. And yeah, I don't know. I think it's a very interesting question. And then like the question of like how do you then solve that, I think is even harder and more speculative. But yeah, I do want to flag that it's like it is like at least theoretically, conceivably, something that we might actually see in the real world.
Amazing. How about Kiran? Do you want to try again?
Sure. Yeah.
Okay.
Can you hear me now? Sorry.
Yeah.
For some reason, my mic didn't go on. So I think one of the slides that Lewis, you presented, you mentioned that there was an exponential sort of, I guess, actions that the agents take from this point where they start, whether it's collective or individual agent. And of course, errors can multiply pretty quickly. So I wanted to find out at what point have you, I guess, experimented on agents where you can say, oh, wait, this is going in the wrong direction, whether it's an action or, you know, or whatever decision, whatever it is, whatever the goal is or objective is for the agent, but both in a collective situation where collective agents decide certain things that are going in the wrong direction versus individual, I should say.
Yeah. Thanks. I will just briefly clarify that when I was like commenting on this idea of like an exponential, and the time to start thinking about what to do when you're on an exponential is before it starts like looking like a hockey stick. The main thing I was gesturing at there is like more the general acceleration, or like the general speed of AI progress and capabilities. And this includes agents as well. So there's a cool blog post actually called, which I recommend you have a look at. It's called A New Moore's Law for AI Agents, or something similar. It's written by some folks at Meta, who are one of the kind of leading evaluation orgs. They work with people like Anthropic and OpenAI and so on, and also the people at AI Digest. And it's cool because what it does is it studies like the abilities of like AI agents to conduct like long horizon tasks. And like at the moment, you know, we all know from interacting with these kind of LLM agents and so on that they kind of struggle with these kind of more complex, drawn out tasks. They can kind of give quick, short conversations and answers, but they struggle with the longer and drawn out things. And they note that it's, you know, it's an exponential curve. So in any case, there are, yeah, so that's what I was kind of mostly meaning to gesture at, and therefore thinking about like some of the risks that can start to emerge at like greater levels of capability and wider levels of deployment are the sorts of things that we should be thinking about now. having said that, I think your question is still actually a very interesting and valid one, more generally. And yeah, if, for example, you have this like flash crash dynamic or whatever, and you see it kind of the curve, it start to like fall off a cliff or whatever, can you develop ways of predicting when it is going to do that before it starts doing that in a really bad way? I mean, I think, certainly there are, right? There are like, methods of kind of like time series analysis and like anomaly detection and these sorts of things that you can do and that you can apply like classic ideas like that. So I think that's very relevant. I think I've thought a little bit less about it in the context of like, okay, how specifically does that change in the multi-agent setting? You do obviously have these kind of ideas of feedback loops where agents can take, it's not a static environment and an agent interacting with the static environment, right? It's an agent interacting and another agent interaction, or more agents interacting. And so to the extent that those agents operate at greater speeds than like a slow environment or a slow human would, then there's the chance that these kind of dynamics can act more, rapidly. But yeah, I would love to see more work on like how do we monitor like complex networks of agents, and like how do we detect if there are some of these like weird dynamics that start to emerge and those sorts of things, and like how early can we do things about it, and what will we do to prevent it? Again, lots of, I think, existing methods, tools, technologies, and so on, both from machine learning and kind of like control and stuff like that, but also kind of other disciplines to make use of there. But not something I have worked on myself. I think it's an important thing that I would like more people to work on.
Okay, great. We're at time. So thanks everyone for coming and for joining us. We'll be back in 2 weeks. So stay in touch with your inboxes. We'll send you the announcement in the next paper as we get the page up. Thanks so much, Louis, for joining us. This was really, really informative. We had many, many more questions from people in the chat, so I can send you those if you want them.
Yeah, please do.
Interesting too.
I've been trying half-heartedly to kind of like keep an eye on the chat, but there's just like too many things and it's going too fast, so I haven't been able to like catch everything. But yeah, I just want to say thanks everyone for your attention, for the great questions, and for what looks like some great discussion happening in the chat as well. If you are interested in working more on this stuff, or thinking more